Good morning, students. I think in previous lectures we have seen momentum equation for bending, sprinklers, reserve. Okay, already I have given for your assignment one also. Hope you all are solving, and I request each and every student to solve the numericals. Okay, because our applied hydraulics is a subject that derivations are important, and automatically numericals are also important. So whatever the numerical it is there, he will go in different ways. We have to follow that one. Okay, now here introduction of dimension. Dimension analysis. Dimension analysis means, whatever the unit is there. For suppose term is a force, some unit will be there, newton per meter square. Area, meter square. Like that, for each and every one, everything we will have some units. That units we will consider in mass, length, and time. Okay, mass, length, and time. These three are important for us. Now here, a dimension is a measure of a physical quantity without numerical values, while a unit is a way to assign number to that dimension. Means whatever what is important here, whatever the dimension it is there, it is like physical quantity. Physical quantity means, like, physical quantity means it will be changed. Somewhere it will be there 10, 15, 20, 25, 30, like that some values will be there. What is that 10? What is that 15? What is that 20? That one we will assign in dimension. Okay, for example, length. Okay, next, length is measured in terms of microns. Okay, feet, centimeter, meter, kilometer. For only length we are going up to kilometers. And there are 7 primary dimensions are called fundamental or basic dimensions. Some primary dimensions are there. One is mass, that is kilogram, newton. These are length, meter. Just now we have seen meter, centimeter, feet, micron, kilometer. Next, time, seconds, minutes, hours. Okay, temperature, like degree centigrade is a electric current, watts we can say. Amount of light we can say. Amount of light also we can consider in watt. And amount of matter. Amount of matter means it is like something like unit. Okay, something like unit means it is also like watts and everything. All non-primary dimensions can be formed by some combinations of seven primary dimensions. Means major major types of dimensions will be in above all 7. Okay, means most of the chances we will get mass, length, time, electric current, amount of light, and amount of matter. Okay, means these are, if you know these all, that is okay. Your uh, uh, means the level will be okay. If you want to go to higher level, the dimensions will be changed. Like just now we have seen micron, meter. Okay, watts, kilowatts, like this. Okay, now for example, force has some dimension. That is, what is force? The force formula is mass into length upon time square. What is our force formula? Force upon force is nothing but something mass. For suppose if I want to throw some object. Okay, if I want to throw some object, I have to consider weight, up to where it should go, length, and with how much time it should be reached. Like you can say cricket. Okay, when the batsman hit the ball, what will happen? The ball may go up to fourth boundary. And if you see at the pitch, the two batsmen are running. What they are doing? They both are running. What fielder should think? The fielder should think that he should out that batsman. So what he will do? He will throw the ball. Okay, while he is throwing the ball, he has to consider time, length, mass of the ball, means weight of the ball, how much it is there, that one he has to consider. Okay, next, that is force is equal to mass into length upon time square. Here mass I am considering in meter, length is same, and t is t square. So here what will be the unit? ml into t power minus 2. Minus 2 is nothing but 1 by t square. Now here are some dimension. You can say mass, symbol is m, SI unit kilogram, English unit is lbm, length meter, feet, time second, temperature Kelvin, Rankine. Here I have shown two units. One is SI unit and another one is English unit. Electric current symbol is I. Ampere, ampere same. Next amount of light, candela, candela. Next amount of matter, N, mole, mole. Means matter means we will consider in same, this one you can say. What is this one? Like molecules, molecules number. Okay, there we will consider mole. Now here one example is this: surface tension sigma s has dimensions of force per unit length. The dimension of surface tension in terms of primary dimensions is, that is, means the primary dimension of this one is sigma s is equal to force upon length. Okay, means we are, if you see in our fluid mechanics first module, we have seen surface tension there. There surface tension it will be denoted in the value of sigma s, and the value the formula is force upon length. Just now we have seen what is our force unit, m into l divided by t square. Same value I am considering here, m into l divided by t square. Length is length. Now length, length will be cancelled. What will be the remaining? Meter per t square. Okay, this is my remaining value. Now here we are having one derivation, okay, that is dimensional homogeneity. Here law of dimensional homogeneity. Okay, every additive term in an equation must have same dimension. Okay, means for suppose you can say a plus b plus c is there. A should be same unit, b should be same unit, c should be same unit. That is nothing but dimensional homogeneity. Consider for an example change in total energy of a simple compressible closed system from one state or other for under time to another. Okay, means here total energy, okay, if it is changing from one state to another, okay, it is changing from one state to another. See here, here if you see in system 1, E1 is equal to U1 plus KE1 plus PE1, U2 is equal to, sorry, E2 is equal to U2 plus KU2 plus PU2. What is this U2? What is this KE? What is this PE? That is important for us. Now E is nothing but total energy and U is nothing but internal energy. What is U? Internal energy. What is E? KE? Kinetic energy. P is nothing but potential energy. Now here, what is this internal energy? What is this potential energy? What is this kinetic energy? We have to see now. See here, here I have shown there is one small jar. Okay, in this jar both liquid is there and some solid particles are there. And some solid particles are there. Solid particles means what? Maybe gas it is there. Gas is not visible. It is like some area. If I am considering both liquid or solid and gas, means the jar, how much jar it is there? Okay, let us take glass. In that glass, whatever it is there, whether it is gas or whether it is liquid, if I am considering both, if I am considering, means the glass, for suppose inside the glass there is some water, inside the glass there is water, whatever the glass material it is there, that glass material will get some energy through what? Due to this liquid or solid and molecular, means the combination of gas and liquid is nothing but internal energy. Now gravitational potential energy. Here I have shown a small diagram. If you see, there is upper part, there is some small surface. At this surface there is one small brick. What it is? Small brick. And here if you see surface of the earth, if it is falling, okay, if it is falling, we are not applying any force, just if it is falling by itself, that movement is nothing but here potential energy. Okay, means gravitational potential energy means whatever it is there, we know one value, that is acceleration due to gravity. Acceleration due to gravity means what? Whatever the object we are releasing at certain distance, no need to apply force, automatically it will fall. That falling is nothing but here potential energy. Next one is elastic potential energy. Elastic potential energy means if you see here bow structure, means arch, you can say arch should work in, okay, arch should you can say, means what he is doing here, we are applying some elastic moment and we are releasing, we are applying some elastic moment and we are releasing. Okay, means this elastic is nothing but potential energy. Why we are doing this one here? To reach our target, to reach our target. Now kinetic energy, I think kinetic energy you should know. the formula is half into mv square. Here m is nothing but mass, v is nothing but velocity. Now shooting a rubber band we can say. Now if you see here, there is a small girl. What she is doing? There is one rubber band, she is playing with legs. Means what she is doing? She is moving, she is pushing that one, or she is okay, she is pushing that one. If she is pushing that one, what will happening? It is going to some forward, and again she is pushing like it, like this. Okay, releasing the arrow from above. Just now we have seen, this is also one of the kinetic energy we can say. What he is doing? Just he is stretching our arch and he is releasing arrow. He is stretching the arrow and releasing. Means this stretching is nothing but here kinetic energy. Here what he is considering? He has to consider arrow mass and speed. He has to consider or not? Target. That is here half into mass into velocity square. That is kinetic energy. Now these components can be written in terms of system mass, measurable quantities in thermodynamic properties of each two states such as speed, elevation and specific energy. Speed, obviously velocity, we have about terms whatever it is there. If you see in all three ways, some speed is there, velocity, that is one. Next, elevation means for suppose arch is there, arch and arrow is there. If he is stretching and releasing the arrow, immediately means what? With some level, means it will follow some line and it will go through it like that. Okay, and internal energy means what is internal energy, that also we have to consider, and known as gravitational acceleration constant. Obviously g value is constant in all. Now delta E is equal to mass into u2 minus u1, and these are the standard formulas. Delta ke is equal to half into m into v2 square minus v1 square, and delta pe is equal to mg into m is nothing but mass, g is nothing but acceleration due to gravity, z2 is nothing but datum line we can say. What is this z2? Datum line or elevation we can say. It is straightforward to verify that left side of the change in energy equation all three additive terms on right side have same dimensions. That is delta E is equal to energy, that is equal to force into length. Whatever energy it is there, we have to consider force and length. Just now we have seen what is the formula for force. See here, ml by t square. Now ml by t square. Here one more, it is a length, ml by t square into length. So finally we will get ml square by t square. Delta U is equal to U formula, that is mass into energy upon mass. Mass cancel, remaining is energy. Just now we have seen energy unit. What is that one? ml square by t square. Next, delta K, that is kinetic energy. The formula is mass into length square upon time square. So here same, m into L square divided by t square. Delta P formula is mass into length divided by time square into length, that is ml square by t square. Okay, now in addition to dimensional homogeneity, calculations are valid only the units of homogeneity in terms of additive term. Means if you see all of this one, okay, all are homogeneous, ml square by t square, ml square by t square, ml square by t square. That is nothing but here unit is same. This is nothing but homogeneous. For example, unit of energy in above terms may be joule, Newton meter or kg meter per second square, all of which are equivalent. Suppose, means here the units are joule we can consider, Newton meter we can consider, kg meter square per second square. Okay. Now suppose, however, the kilojoules were used in the place of joules for one of the terms. Means instead of joules we will consider kilojoules. Okay. This term would be offered by factor, that is 1000 compared to other terms. Means like kilogram. Okay, kilo means obviously it will be 1000 joules. Okay. It is wise to write all units when performing mathematical calculation in order to avoid such errors. Okay, means whatever it is there we have to write in order, then only we will get clarification whether it is correct or wrong. So in next lecture we will see some numericals on this one. Thank you students.